Okay, so in English. So I would like to welcome you all to my Smart presentation. I had Smart about a year ago about ML.NET, which is a library that Microsoft develops for all kinds of machine learning. Back then it was version 0.4, I think, or 0.5, so it was some beta version or pre-release version. And over the course of the year, it has moved and it is now stable release 1.3 or something. So it's Microsoft considers it production ready. So first, I would like to talk a bit about what is machine learning and AI or artificial intelligence in general. It is essentially some statistical analysis over the data. You have some huge blobs of data and you are trying to find some patterns in it and extract some information or somehow complete it. What will you find depends on what you are trying to find and what kind of approach do you use. You can predict what piece of or which group it belongs to. This is a typical example for self-driving cars, where they use a camera which takes a picture or takes a video of the road, and it tries to find traffic signs and determine what kind of traffic signs this is. Is it a stop sign? Is it a main road sign? Or to know how to react when I see this kind of sign. If you are self-driving, you are in a self-driving car, you wouldn't want it to ignore a stop sign and just go through it. Of course, you can use it to predict future values, such as one application could be to predict stock markets. How is it going to develop? Of course, that is hard because there are many variables on what can go wrong. Nowadays, a tweet from CEO can make the stock value go up or down significantly. So that is something that you can't predict. The same way you can detect spikes. If customers are buying something during a certain period of time, you can detect, oh, right here was some spike, here we got some more than usual. And normally you would plot it in a graph and you would see a huge increase, but there can be slight nuances to that, and it might not be that obvious at first sight. That's why you would use machine learning. I would go over some brief history of the ML.NET. Before 1.0, it was just getting it all together. They had some easy to use API. It wasn't very good. I wouldn't say the new one is an improvement, but at least it's more complete. Over the course, after the release, they added some more support for features such as using TensorFlow models or using it in API, detecting images, some work to try and extract some info from images. And current version has deep neural networks using TensorFlow. I will go over how TensorFlow can be integrated with it, and I will tell you how well it works. And in the future, in the roadmap, they want some improvements in general over TensorFlow, and to have some connector to a database, because normally you would have the data in some CSV file. My example is in having the data in CSV or some XML or some other format. But of course, when you have gigabytes or even terabytes of data, it's using a CSV for that is not very good. So you would probably store it in some database and just load it from a database. So I would some words about the API. The way the machine learning works is that, or in ML.NET, is that you declare a sequence of steps, what should be done with the data, how it should be processed, how it should be used in the training or learning, and what to do after, potentially, or that's optional step, what to do after you train the data. Then you load you have like a description of a pipeline. Then you take the training data and you fit the data to the pipeline. Then you will create a model. Model is essentially you will run the data through the pipeline and it will produce some result. Think of it as the algorithms as being some black boxes that have many internal variables. And by running the data through the black box, you will set the internal variables to their values. So if you want to store the model somewhere or serialize it, so if you would like to reuse it, you train the model on some training data, and then you would like to deploy it to production and use the train model. All you basically do is serialize the internal variables of the model to a file, and then you load the file again and set the internal variables, and you have the model loaded. So it's you don't have to train every time you have a web API and you would like to on the fly do some predictions. You don't have to train every time on the training data. You would just take the serialized model, which is already trained, and then load it. And the API then creates the prediction engine, which is somehow a way how to predict the data. I will show you more in the sample. So here is how the old learning API looked. As you see, it's the same, or it will be the same as I will show you later. Is that we will create a pipeline, then we will create what we will add to the pipeline the steps to do. So first we load the data. So we give him the path, what to read, which is a text loader. Then we put the constructor. I will explain later. That's the same. We tell him use this algorithm with some values, and we will tell the pipeline to train. They changed it a little bit because here we are in the pipeline, we are loading the data. They change it so that you just declare the pipeline, and then after the pipeline is created, you will put the data in. And again, I will have that in the sample, and I think the sample is next. Yes. So what exactly is then going on? Here. So everything is centered around ML context. If you are familiar with the framework or just in general having some context, you will expect context to be disposable. At least all the contexts I have ever encountered were disposable. This one isn't. This context is like a treasure box of all the things you can do. First, if I just show you what it contains. Just here, I don't know if you can see well, but you have all the possible things you can do. So you have algorithms for normalization, binary clustering, so on, regression, transforms, forecasting, predicting something in the future, and you have some data. So you can, it contains even things like loading and saving the data, or transforming the data. So the first step is to load the data when you are trying to do something. So you go to the context, you access the data, and you load I don't know, step, or not really a step, but something to tell him load from text file this data. It's a CSV, so you tell him what the separator is, if it has header or not, just to show you how the exact data set looks like. It's a Iris data set. Who is familiar with it will know. Who isn't, I will explain. So Iris. Yes, it's in a good package. Yeah, I will tell a bit more about it later. So Iris is a basic dataset that is probably the most popular learning as in you are trying to learn something about machine learning, you will probably use this data set. It's quite simple to I will show it. It's detecting type of flower based on its properties. So you will, so what it does, it measures the sepal and petal lengths and weights. So if we look at the pictures of these three flowers, we see that this versicolor has the sepals very wide, the petals are not that very wide. Setosa has them narrow, and the petals are very, very small, and so on and so on. So what this data set tells us is that if we look at if somebody measured 150 total, I think, yeah, 150 of these flowers, and measured their lengths and widths of the leaves and classified them as some type. So we have some setosas, versicolors, and virginicas. So what I will show you in the sample is to train the model and then just putting the lengths of the leaves to the model, and it will predict what kind of flower it is based on these training data. So normally, you know, this wouldn't be possible. I think without machine learning, you would have to have some ifs and so on. Here you will tell him, here is how 150 of these flowers look, and then ask him, if I give you this flower, what will you predict it as? It's not 100%, of course, it's just kind of guessing, but using some algorithms you can get on these kinds of cases almost 100% accuracy. So back to the sample. Here we loaded the data. We load this CSV file, and this load from text file will parse it and return something that's I data view. It's in the I don't know if you can see it in the documentation, but they compare it to I enumerable. It's just that this enumerable is good for or supported by the pipeline or by the ML.NET. You can load the data from enumerable as well, so you will just call a different method to transform enumerable into this data view. And in the future they want to add a connector to SQL database, so you would just connect to SQL database and it would produce this data view. Then you define the pipeline. It generally, when working with machine learning, you are working with vectors. So n-dimensional vector, which is just a collection essentially of numbers. Like you can think of it as fixed array of numbers. So here you put all four of the parameters, because if you look at the input, it has the 4 parameters and then the label, which is what is the actual prediction. But we don't want to show the algorithm what was predicted yet. So we will put it into the features column. This is something that I really don't like about it, is that you have to name the column yourselves, and it expects certain columns to be named as they are. So it expects to find column features. I don't know why. You can probably somehow change it. I didn't find it how, but yeah. So you just create some vector, then you tell him to map some values to keys. It's not important right now, it's just to have a nice output. Then you tell him what kind of algorithm you want to use. So here you have a lot of, or actually 4 only, oh no, more algorithms to use. So I just put this one, I don't know why, I like the name. And then you do some processing again. You have the pipeline defined, and then you tell it to load it, to train the data. It will create the model I was talking about. You can save it to disk and then predict. So instead of telling you what the is going on, or rather showing you. I will show you with example what it does. If I run this code, it will take this input. So we are telling him that the leaves are this big. So 1.5 centimeters, 2 centimeters, 3 centimeters, and 2.4 centimeters, and ask him to predict what he thinks this flower is. So what he will do, every time I run this code, he will load the CSV, he will train the algorithm on the CSV, and then take that one single input and try to predict it. And it takes quite a long time because the training is expensive, because you need to load, okay, in this case just 150 rows, but imagine you have million or 2 million rows. So every time you would have to read 2 million rows, train the algorithm, which takes lot of time because you are doing mathematical operations, setting the internal variables, and so on and so on. Then saving to this, that's probably the easy part. And doing the prediction. The prediction is not that expensive, but still, it's been running for how long? 30 seconds, and still we don't have any output. Okay, now. Yes. So that's the problem, that the training is expensive, really, can be really expensive. So, and it predicted it as setosa. I don't know if it's correct, I just picked the values randomly, but it predicted as setosa. That's why it supports loading it from file. So instead of training it every time in, I don't know, web API or something, you tell it to load some file, which is the serialized model I was talking about. So the collection of internal variables, you will load it, create the prediction engine, and do a single prediction. It's of course much faster. You can even, instead of loading it from disk, you can load it from a stream. So it can be in memory, and then every time you would just access the stream and predict it. This will be, of course, much faster, and as you see, it's much easier because you just load the model, create the prediction engine, which is the engine to predict, and then you give it the input. And if I run it, it will be much faster. 1 second. So it's much better. So the way you would be supposed to or using it is that in your build process or somewhere you would create the model. So you would have some code on the side, and when you try to or want to deploy your application, or before, you would run the training, which could take on with on huge amounts of data, minutes, even hours. Create the zip file. The models are serialized as zip files. I can show you how it looks inside, but it's not very interesting because it's a binary file, or all of them are binary file. It is some here. Now if I open it, it will tell me that this is binary, so, and it's some garbage. So I don't know how what is going on inside, but it's a small zip file. In this case, it's just 4 kilobytes, those 150. And if I, the more data you have and the more columns they have and variables, the bigger it will be. So it's not, I don't think it's supposed to be used that every time you try to predict something you will do all the training. That's of course stupid, because sometimes the training can be fast, sometimes can be slow. So this is the proper use case. You would train it beforehand during your build process or even during development phase, and then just put it to your application and use it. I will show you later how it's interact with web API, how it has support for it, and how it can be used together with Azure, for example.
you can use the service from Azure which will train for you.
I'm not. Azure has some machine learning tasks, but I'm not sure if they can train using this ML.net. But you can have your own program or use AutoML. I will show you what is later. It basically does everything for you, and just take the zip file and store it on Azure and have a link to it to be accessible from Azure or some other place. They or have it in Azure function, and that Azure function can receive it as blob from Azure. It has support for everything. And of course, important part is to evaluate what you are training, because if you train the data and then you say, okay, that's it, without checking how well or how accurate it is, what's the point? Because if you get 20% accuracy, there's no point of putting in production, because it will be missing most of the predictions. So this is why it includes the ML.NET includes some task or steps to evaluate how well the model is doing. So what's the general idea? The general idea is that you have some large number of data. In this case, I had 150. Okay, it's not large, but 150 rows. I split it here, uh, 10, 10 to 90. So I will take 10% of the data randomly chosen, put it on the side, and then the rest of the 90% I will train the model. And then I will run those remaining 10% through the model and see how well it predicts it. But because it's a training data, it has the flower name in it, I can compare the result with the actual result in the file, the tested training file, with the result of the prediction. So, and I can calculate some accuracies, the percentage accuracy. So here it works exactly the same. I will put it in the features column. I will do some I do some other things around it, and here I wanted to show you how the algorithms compare to each other. Then here you just do here is the where we train the model, and here is transform. The way it normally works is that you would create the prediction engine and predict a single entity, single input. But if you want to predict multiple, an array or list of inputs, you would use this transform. It would give you as the data view, and I think you can do somehow you can get it to enumerable, I think. I don't know where exactly, but you can transform it to the instead of having it in the iData view, some internal collection of the ML.NET, you can transform it to enumerable of the output type, so we'll have it strongly typed and it's all nice. And then you just tell him to evaluate this data. Uh, uh, and it has the evaluation will give you some accuracies, some macro and micro accuracies, and some other things. I will not explain what's the difference between macro and micro accuracy. For those who want to know, it's that if they consider the class in or not, it's not important. But you see that it achieved just 33 and 11%. That's not very good, of course. Having 1/3 accuracy is bad. So if we go back to it and change the algorithm, let's use this one. 0.8 and 0.66. So that's much better, but still not very good, because just having 80%, if it's something important, then would you put it into production and say, okay, we have 80% chance of being correct? Probably not. And what I wanted to show here is that if you notice, I have these as the CA maximum entropy, and here is the same as the same maximum entropy. But in these cases, I can give it some variables. You can sort of push or nudge the algorithm in some direction by telling it, okay, I want you to, you are setting some things internally, but you are using some values to do it, you know, some learning rate, or how fast to, or some steps, or how big is something. So you tell him, instead of you, the algorithm, which is very smart, deciding on these algorithms or using some default, or on these variables or using some default ones, I will give you these values. So you tell him, use this L1 regularization at 0.2 and this L2 and 0.4. Again, I don't know what they are. You would, you know, you would have to understand. You would have to know what exactly this algorithm does. I know the general idea. I don't know the internals working of it. So uh, it allows you to somehow play with the algorithm and or trainers and algorithms to find the best possible value. So if you don't want to play with it, you can just keep it empty. It will use some default values, I think, and it will give, if everything is alright, pretty good result. Or rather, it doesn't use default values. It tries to find the best possible values. So instead of Microsoft hard coding 0.1 here, 0.5 here, it will just iterate multiple times, try to find the best two values, and it will use that. So as you see, it takes quite long time. It will take around those 50 seconds as it did the first time, because I'm using the exact same step as I did before. It does the exact same thing, with the exception that it uses 10% less data and then tries to predict the data. But that is insignificant compared to the training time and the time it takes to search the space for the best values.
I guess if you data scientist and you know this algorithm, your programming of the training would be much faster because you would have better guess, right? You would.
You could have better guess, but I think still it's mostly about research. You're still, trying to find what fits the best.
I mean, that's what I wanted to ask. Like in one extreme case, I'm data scientist and I know this algorithm and I make really good guess. So I will do these, what you've done,
Yeah.
these lines commented out, I will guess it right and I will get the best prediction best. That's when I'm like an expert.
That's possible.
And when on the other extreme, if I don't know anything about that, it's just like a names for it. I will mechanically try different variants. Yeah. And now my question is, can this mechanical trying different variants be done for me by the framework as well?
I will show you. It's not by the framework, but it's an extension to Visual Studio. It's called AutoML, and it's at the end of the. It does everything for you. It finds the best way, best algorithm, best everything, and it will create everything for you.
Realistic to do some model even if I'm not a data scientist? Or
Yeah, I wanted to talk about it later, but okay, let's open it now.
no, it's okay. If I don't have to know now.
I wouldn't put it in like.
If you are a data scientist, I don't think you should be using this, because it's not complex enough to satisfy your needs, because there are many other great tools such as the TensorFlow, which is I think from Google, and it's like the leading edge of the technology. It's the best you can, or one of the best you can get. There is some, I think, CNTK from Microsoft, some others from Amazon, and so on and so on. So if you are a hardcore data scientist, you would most likely use some other tools because they are more suited for you. But if you just want to, or if you are a .NET developer, or you work on a project and you want to use some machine learning, some easy machine learning, not something big, not something hardcore, it could be a good way for you to get some basic machine learning in your project. And of course, it can be integrated with TensorFlow somehow. I will show a bit later. And so you would have some data scientists working with TensorFlow, create the model, serialize it on the disk. You would have some, the TensorFlow models are quite big, but some megabytes of data that you would just load and use this ML.NET to make the predictions. So it's not really a tool for data scientists. It's more like for .NET developers wanting some machine learning in their project, some easy integration. For amateurs or for some easy to use. Uh, so it finished. It took twice as much time as before. I don't know why, but it varies. You can never tell. This will take 60 seconds, and you have 88% or 89% accuracy. And if we play with it a bit more, you can add some normalization, which is reducing the data to values between 0 and 1. You can do some principal component analysis, which is detecting which columns are the best to use. So on, it's if you are a data scientist, you will be familiar with these. Or if you studied at some university, some hardcore math or statistics, you would know these terms. Because doing machine learning is not only about picking the right algorithm with the right parameters, it's more about getting the data, preparing it for it, finding what is important, what isn't important. I don't know if what sample. Okay, if for example, if we take this iris data and we say, okay, we classify the type of flower based on its the length of the leaves, as I shown in this picture here. So you see that this is huge, this is small, and so on and so on. Someone decided this is enough. But what if somebody who measured it also included how tall the flower is? Would it be useful information? Because when you have a real world application, you will have a lot of data, even useless data. So probably in this case, how tall the flower was not a really important part. So they skipped it from the data set, which is freely available, and so on and so on. They wanted to have just what is important and compare it to the label, or the label which is called the result. So in a real world example, you will have a lot of garbage, and you have to shift through it, find the important things, do some mathematical statistical analysis on it, transform it, and then you can run it through the machine learning. So I won't probably be showing more of the algorithms. They all, some are better, some are worse. You just evaluate it and so on. So it's a good way to try something and see how well it works. I wanted more talk about the web API. The
Value of parameters are is part of this library. The way how to
yeah,
I forgot the name for it. It's like weight of
yeah,
parameters or
they
something
have
like.
here. If you do some preview, they we have and you give it the yeah. I don't know exactly how it works, but there is a way from Microsoft to debug or see what is going on inside.
Because sometimes even some parameters are breaking the model.
Oh, you mean that way? No. That's no, no. You mean the input to the training data, the input. So if we have this data set, if we said okay, this fourth column, it breaks the data set, and the algorithm will show you. That's what you meant.
Yeah. It's sometimes okay. More is not always better.
Yeah, exactly. That no, that it's not there yet.
I don't know if it will be there or not. But it can show you when you are training and the algorithm is setting its internal values. With each row, it will move it slightly. You have some debugging to see what is going on when it's training. But so
It could lead you to somehow finding the problem, but I'm not sure if it will allow you to say, okay, this column is useless, this column is not. That's why I said that it's not very good tool for hardcore data scientists, because data scientists will take some Python or some R and just run some tons and millions of statistical analysis over the data and some do some transfers, and he will see with some numbers and with some analysis that okay, this is useless, this is very good, this is okay, but I will keep it. So it's not really prepared for being leading player in the machine learning board.
I thought it's the intent today.
Maybe in the future, but at the moment it's very clunky, and that's with the TensorFlow. But because I will show you later, it didn't work for me, the TensorFlow. They promise it works, but it didn't. So moving on, the web API usage. The prediction engine which we create here to predict the single value. So imagine every time an request comes, you would have to load the model from the disk. That takes some time. Create the prediction engine. That takes some time, and then predict. Of course, the best would be to create the prediction engine once at startup, and then just call this over and over again. But it's not thread safe because it's using some internal variables. It might be changing things. It's stateful. It's not stateless. That's why they created a nugget, an additional nugget. It's called Microsoft Extensions ML, and all it does is it allows you to configure it as service. So it will create a prediction engine pool. So object pool, you have multiple objects, like a thread pool. You have multiple objects in a pool, and when you request it, it will give you one. When it's out, the thread is blocked until another one is returned. And here you will just load the model from file, create register it as service, and in controller you will inject it as normally you would, and then in method you would use it as as you would want to. So you have some class that you would just call predict on, and will give you the result. You don't have to handle loading the data, training the data, and so on and so on. I have this API project in Azure, so I will just show you how it works. We call the API. I'm not doing some magic here. I'm just calling this URL with some data. Nothing that's, and I'm using some low cost tier, so it took some time because it had to spawn up. It's not being used, so I think if I run it again, it should be, already running, and should be much faster. Yeah, this is faster. So 1.5 seconds with some overhead. Okay, it's not the fastest, but I'm not using the highest Azure tier. And of course, there is new hype going serverless, where you have the functions which is just a which is like a method that does one thing, and it in .NET it can be have multiple triggers, such as having a timer. So you deploy it on Azure, and every n seconds it will do something. It can have trigger on event. So you post events to Azure, and when it registers this event that it's programmed to listen to, it will run. The same with HTTP. You send a HTTP request, and it will return, read it, process it, and return a result. The benefit of it is that when you deploy it to cloud, the function only runs when it runs. If you deploy a API or a regular web project, it's running all the time. Even when nobody is using it, nobody is accessing it, Azure still somehow keeps it alive, and you are paying for it consuming processor time. But the function, you are paying only for the time it actually runs. There is no like application pool that keeps it running. It's just you call some specific website which with HTTPS. It knows it's a function. It runs small snippet of code, and that's it. And it runs, I don't know, half a second. So you are only paying for that half a second of runtime. If you call it 3 times a month, you are paying for 1.5 seconds of runtime to Azure. And you don't have to have entire instance of API running, which would cost you, I don't know how much. I had some problems with getting this function running in Azure and with ML.NET. That's another reason why I think it's not really for hardcore people. The problem was that the ML.NET requires 64-bit architecture, and it requires some native APIs, and I was not able to get it running in Azure because it was crashing. I made sure I was running it on Windows, on x64, but it didn't work. So I will show you how it works locally. The function is quite simple. You can think of it as a like a single method controller. This is the entire code for the function. Again, you have constructor which includes the prediction engine pool. It was what I showed you in the API where it loads the data, but this time the difference is that it can load it from URL. So here's some URL to Azure Storage where I uploaded the model, and I told them to every 2 minutes check if there's a new version. So that's up to you if you want to have it on file or have it on some another access or another server. And if you decide, okay, I want to load a new model to you keep the function running and then just retrain it, and with more data you would just upload the zip file to the storage, and it would in 2 minutes it will pick it up and have a new data available, and it could be running without the need of deploying anything. So the function here, I just tell it that I'm telling it that there's no need to inherit from something. You just say, okay, this is a function. It has this method where it loads the request, that it's a HTTP triggered request, and accepts only post. And it reads the body, does the prediction, and returns the result. Nothing fancy, just exactly the same as this, except there's a bit more code because it doesn't accept like you can't type in as you would in controller. You would put the exact model name, and it would deserialize it, and the model binder would bind the data to the model. You have to deserialize it yourselves because you can access the raw HTTP data. Again, if I run the console, it will, here we see the function, and it should, yeah. So here is the output of the function. Here is the output of the HTTP request. Again, it predicted as Aristotle's, and we see here the function that some logging that it executed the iris function with this request, how long it took, and so on and so on. So it's one way to do machine learning in web, is that have that single function where you're only paying for the time it runs. It could be part of your API, or it could be like this. It's of course up to your business case, but I quite like this approach for small tasks, like a kind of microservice thing, because it really runs, and you only really pay for the time it actually run instead of having the entire project or the project running 24/7. And now coming up is the TensorFlow. I have, yeah, is it boring? So TensorFlow, as I mentioned few minutes ago, it's a machine learning algorithm, or not algorithm, machine learning tool, and I think it's from Google. It's state of the art, I think. It has support from Python or in Python. So you would program it in Python, which would call some C level APIs. You can download the TensorFlow C API, DLL, add it to your .NET project, and just go via what's it called? Interop. Yeah, interop. Thank you. And there are some .NET libraries that create a wrapper around it. But it's not using the intended way of Python is still better if you are familiar with it. And TensorFlow is like more complex ML.NET. It can do everything. It has support for multiple algorithms. It has support for advanced algorithms, for data processing, for basically for everything. It's just I haven't played with it, but I heard that a lot of people are using it because it's just that advanced. And Microsoft, when developing this ML.NET, I think they very cleverly mentioned that they will add support for TensorFlow, but they never, I think, specified what will the support look like. Everybody thought, including me, that it would be some wrapper around TensorFlow, and you would be able to write TensorFlow learning and basically control the TensorFlow from C#. But it's not the case. What it only supports is that you train the model in TensorFlow somewhere else, in using the Python or something else. You save the model to a disk, and then you load it in the ML.NET and use the already trained model to make some predictions. So it's not that you will use all the features of TensorFlow, you will just use the prediction and you have to get the model elsewhere. Microsoft, when they shown it on in their documentation, they have sample sentiment. It's a collection of, or it was a TensorFlow model trained on movie reviews from IMDb, and it tries to predict if the review is positive or negative. So if the review was "I like the movie," it's a positive because it's saying okay, the movie is good, and if it's bad, then it's negative because it's telling the movie it's not a good movie. The actual workings is a bit, or the actual usage is slightly more advanced, because here's the problem is that it accepts fixed length review. So I think it's 600 words. But if you type in just "I liked it," that's 3 words. So here what it's doing is that it first tokenizes the review. So "I liked it," 3 words, it splits it into 3 words. Then it does some dictionary or not dictionary or mapping of a word to some number. So the words are represented as numbers, and then it resizes the vector. So the vector of the "I liked it" would be resized to 600 length, and the rest would be empty. And once that's done, it just loads the model, does some scoring, and then copies the columns. That is to have some nice outputs. That's not important. And as before, just create a prediction engine, predict it, and it should only have two predictions. The prediction is array of floats, and the first element is positive and the second is negative, so it's probability. It's between 0 and 1, and the sum together is 1, so it tells you 70-30, so that's probability of it's positive, and probability is negative, so whichever is higher is the result. So how well it works: if I run it like this from Visual Studio, DL not found. Okay, fine. And in the documentation they say all you need to do is add a specific TensorFlow ML.NET nugget. No more you need to do. I figure out if I do publish and actually publish the website, the application. Yeah. Ja,
Soon, or if I'm doing something wrong, but I tried. That's all I can say.
I don't know anything about it, but is there some like catalog of these, some kind of open source models someone prepared you can use in your application?
Yes, but they are not. It's mostly about training. No, not training. Learning about machine learning. It's not that you can download some magical data set that you really need.
No, I mean the model, not the data set.
There is something called that's what I wanted to show now. Okay, so as always, ONNX is this is not what I wanted to show you, but I will mention it. It's another format of exposing the machine learning models. It's an open format, it's open source format that can be shared, I think, from TensorFlow to ML.NET to other systems. But there are libraries of models. I know there is one, I forgot the name, but I can check it later. It's trained on images, recognizing what is in an image. So you take a picture and it can recognize, if I take a picture like this, that's a pizza box, that's a remote controller, and so on. So that exists. I forgot the name, but I can tell you later. That one I know exists, and I'm sure there are other ones, and there is even some database of training data, sample training data that you can use for all kinds of features. There is even one for about credit card frauds, and I haven't downloaded, but it's
Well, that's the data set, it's not the finished model.
I know the image recognition is the finished model. It has. I probably killed my Visual Studio because this file is pretty big, but this is the dataset for credit cards. It tells you if the transaction was fraud or not. And if you look at it, you won't read anything from it because it's been run through multiple analysis to transform the data. You know, it's like, I don't know, enums. They won't get, you know, translated to their string values. They will get assigned some random number or something. You know, but that's ah. And the last thing I wanted to show you. So or I was not able to get TensorFlow working, but it's supposed to be there. But there is another thing which you asked about. It's finding the best algorithm for you or whatever. It's something called AutoML. It's an extension to Visual Studio. It's not 100% done. It's some beta ML.NET Model Builder. It's in preview. But I found it works good on some things, not so good on other things. All you do is you add here, it's machine learning. You pick what you want to do. So it supports two or three out of the box, and the custom scenario you have to tweak. The sentiment, you split it into two categories because the movie review, good, bad. Issue classification, this is multi-class classification, it was the flowers. You say you split it into three or more classes. So which kind of flower it, you can extend it to have 100 classes if you want. All you need is the good data for it and some numeric value from, break the price of the house. That's the sample. So I'll pick this one. It has support for SQL here. The amount that I don't think it has yet. So you select the file, the dataset, the CSV file. You tell them I want to predict the label column, which are the input columns. If you know some is not good, then you can just exclude it here. And here how long it should train for. Because if you put in 3 hours, then it will 3 hours will try all kinds of different combinations. If you put in 5 seconds, then it will run 2 tries and that's it. So let's put 30. And it starts working, doing something, and it's at the bottom here. You see how it tries to run through all the different kinds of algorithms and the accuracy. So here 1.1, so 100% accuracy. What it does is what I showed you in the evaluation. It splits the training data into one small as a testing, one small as a training, trains it, compares the testing data to the result, and handles and calculates the accuracy. And it does that here 25 times. You see that after a few moments it starts to repeating, but I think it does it with check different values because here it got 9375 and the same algorithm a few seconds later got 7895. So much lower result because he tried a different value and it didn't work. After it's done, you will see that it's some what's going on. How like this one was good. Of course, here is okay.
It wasn't me.
Okay, so summary what happened, and then just spread and it will generate projects for you. Yeah. So here it created the model. So it took the training data, the boring part, and created the zip file that you can then use in the application. And of course, and again, it created the input. So you have the input data in a nice, of course, you can rename it, press F2 and rename it to whatever you want. That doesn't matter. And the output here, it created some basic way how to consume the model. It's not perfect, probably should be using current domain based directory to access the file. You have to play with it a little bit, and here it created.
So it created one project for training the data, another for consuming.
Training and some running, create some console app. But yeah, you can take this one. You should be able to take this ML, this model, and put it in your project, and you are pretty much done. And the console app is just it's doing the same thing. It just taking some testing data from the file. It picks a one random value or one random row and actual label from the file Setosa, predicted Setosa, and here are the weights. So it was 99.77% sure it was the first label, which in this case was the Setosa, and 0.22% sure it was, so it will show you the scores. So that's a nice way to get some easy machine learning done just by clicking 5 times and getting some output projects. And it will find the best value. You can have it running for 3 hours when you have something complex. Just let it run for 3 hours overnight, and you will find probably the best that you can get. Taken. Yeah, that's it. So thank you. And if you have some questions,
have you tried any like a sample of your own? Because in like on any machine learning session ever, there is this flowers example.
Yeah, I know.
But I'm wondering if you really had like any problem that is not like prepared so that it can be fetched to that neural network. Would it be actually, or how hard would it be to actually to put it in a shape that you could use it for such predictions?
I have tried. I downloaded the data from the CNN attendance system, mine attendance, and I tried to predict, based on when I arrive, when I leave. But it was too few data points, so it didn't work. But that was because it was not precise enough. It was data just for, I think, 6 months, so that's probably not very good. But otherwise, no. I think the problem is that I will show the credit cards in a different. This is data about transactions on cards. As you see, it was run through principal component analysis. It's a analysis of detecting how well certain features are relevant to the result. and here at the end it's either 0 or 1, there are not a lot of ones. If it's a 0 is not a fraud and 1 it's a fraud. And the problem in general is that you have to do all this mostly. So if you have your own data, if they are good, then sure, you can use it.
Yeah, but I assume that's the biggest issue, that you need to find a way to turn it into a vector of fixed length.
Yeah, that's probably, yeah. But if you are using some SQL database, then you already have vector of fixed length because you have fixed amount of columns, and if there are null, then you replace null with 0 or something. The problem is that if you have a lot of data, as Mira said, then more data does not always mean it's better, because you can introduce some bugs, not bugs, but like that values in the system.
And also sometimes it's really tricky how to let's say transform value to the vector. For example, first name, last name. How to transform it into the number. Good luck.
But I would say that first name, last name shouldn't be like a part of to decide if
it could be. When it's fraud, sometimes they use some patterns in names. It could be relevant. You don't know. Like, for example, I saw some advices like if you want to use boolean in this data, don't use it like 0 and 1, but use it as like -1 and 1. And he spent like 20 minutes explaining why it's a good idea. And so there is so many details you need to keep your attention on that it's not really so simple to put it in 1 hour.
But this is not just a problem of the ML.NET, it's a problem in machine learning in general, because okay, it doesn't have the features to help you transform the data, and TensorFlow perhaps has, or if TensorFlow is programmed using Python, then you can use NumPy or other numerical libraries in Python which support it. So it's about, it's a problem in general for machine learning, and .NET right now, the ML.NET just supports basic functions and models that were trained elsewhere, or the data sets input that were transformed elsewhere. I will check Slack if we have some questions.
I actually had when I was thinking about learning it, I had an idea where to try it, and I don't know how realistic it is. But I do sport climbing, and in sport climbing, most of the sport climbers, they keep the diary when they go climbing, what grade they climb. And typical pattern is if you go climbing often, you can climb harder and harder grades. So I was thinking, like, if you can use this data, and of course, like, if you go twice a week, you will reach higher grades either. If you go 3 times a week, you even better normally, right? And if you stop climbing for a couple of months, your climbing grades go down. And I was thinking, if you can, if a lot of people, there's a lot of websites for climbers where they keep their diary, so there must be a lot of data where people say, okay, this week I climbed grade 5, 6, 6, 7. And if you can train the model and then run scenario, okay, if I go climbing 3 times a week, would I be able to climb this grade or not?
I think that could be possible, because you have to just get the data. So download the diaries of people, have a lot of them, and have timestamp next to each other. And even I really don't know how it's called right now, but it's like a time series prediction, where it actually looks at the time, even at the timestamps, and it tries to predict based on historical results, or not linear time or so on, the future values. So could be possible, but
isn't it more like for some regression? Because as I understand it, this is mainly for classification problem, and this is more like prediction.
But it allows regression. It has if you look into the bank of features in the ML context, it has regression engineering. So it has these 3 regression trainers.
But I was thinking something like for someone who never done this, to worth of trying it or not. Like, would it be that like for complete novice to try to create model like this or not?
You will learn on the way.
Well, I
When
don't
you
know
are
the
done, you
best
won't be
if
a
it-
novice. I really can't tell right now. Up to everyone how well he wants to, how much time he wants to spend.
Well, that's the thing. I don't want to spend some time finding out that it's waste of time because I would have to learn so much that it's not realistic.
Are there any general rules how to transform certain kinds of data into these numeric vectors? You mentioned words, for example, that you can have indexes for.
Generally, in this string, you would have some index maps or word map that we would. If you have fixed data, then you just fix values, then you can easily create a map.
Yeah, but my question
I know.
was like if there are some good practices, like for.
I'm not aware of any good practices. I know that numbers are pretty simple. Some Boolean values, that's up to you on 1, 0, -1, 1, and so on. Enums or so on. Then that's one again mapped number words. That's because the ML that has some support for words. So classifying or working with text is slightly different than just working with vectors, counting of text as a numbers vector. But I'm not sure right now.
I think there are some, let's say, ways how to do it, but I think that it should be another 1, 2 hours lecture how to transform data the best way. Like I saw that one guy tried to transform cities like the map, and then another guy transformed the same cities like GPS coordinates and calculate the distance from some point and so on and so on. So there are some good ideas how to do it. There are very bad ideas how to do it, but I think it's usually part of solution how to transform data.
So thank you very much.